Hello friends, welcome back to this video lecture series on data structures, and we were discussing something about sorting. Now today we will discuss about a new type of sorting algorithm which is called as selection sort, and we will study the algorithm and see what are the analysis part of this algorithm. So let's begin. Selection sort algorithm is used for sorting an array with elements a1 to an, and it works as follows. It has some n minus 1 passes. In pass 1, we find a location LOC of the smallest element in the list of n elements and then interchange a LOC with a1, and now we had a1 in sorted position. So the pass one requires two basic operations. The first operation is to find the location of the smallest element, and then it requires you to swap the value of the smallest element with the first element of your array. In this way, you place the smallest element in the first position of the array, and we can say that A1 is sorted. So once after this pass is over, we increment to a next pass, which is called pass 2. Now we find the location of the smallest element in the n minus 1 elements. That means we are now one element shorter than the previous stage. That is, we are going from A2 to AN and then interchange the value of the lowest element, that ALOC, with A2, and now we have two numbers sorted, that is A1 and A2. We will keep on doing similar iterations stage by stage in passes by passes till we reach pass n minus 1, in which we find the location of the smallest element, that is an minus 1 and an, and then we interchange ALOC with an minus 1. So now we can say that we all the numbers from a1 to an will be sorted. So to sum up, we require n minus 1 passes to sort an array A of n elements. Now let us see this selection sort algorithm through a simple demonstration. Suppose we are given 8 elements like 77, 33, 44, 11, 88, 22, 66, and 55. On the left hand side, you can see that there is a column called pass, and it has k is equal to 1, and LOC is not defined right now. K is equal to 1 represent the first pass, and as we don't know the position of the lowest element, we need to find the position first. First of all, we have to find the position of the LOC, and then we have to interchange. As a human being, we can see that 11 is the lowest among all the numbers and 4 is the position. But for a computer program, we have to write an algorithm that can do it in successfully in some steps, and it can iterate it again and again to find successive lower element, smaller elements. So how this workflow actually is implemented, we will see with the help of this small example. First of all, we will scan the list from left to right to find, in order to find the smallest number, and we will do this iteratively again and again for the sublist as well, right? So we find that the number is 11. The how we find this number 11, or how we find the LOC is equal to 4, we will actually see in the working of the algorithm of selection sort. But as of now, to understand the workflow, let's assume that we somehow found that the number 11 is the smallest and the location LOC is 4. Now what to do next? You saw that earlier this LOC was blank. Now this LOC has a value 4. Now, what the second step in pass 1 says, that once we find the LOC, that is smallest number, we will then interchange this LOC with 77, that is the first number in that list. And when we will interchange these two, these 11 will occupy the first position and 77 will occupy the fourth position. In this way, what we did is we have now sorted 11 to its correct position, and we will place it here. Now, once this is done and I have successfully sorted one number in this complete list, I will move to the next pass, right? K is equal to 2 is the next pass, and for this, my list is now range of 33 to 55, right? It will not include 11. Now, the second pass, I will again go and search the smallest number and I find that number to be 22. Then what I need to do is I will exchange this or interchange this number with 33, and I will swap these two numbers, and now I find 22 is the right position, right? Then my number is the next number that I will be searching is 33, and I will exchange 33 with 44, and I will do the same iteration again and again until I get the completely sorted list, that is 11, 22, 33, 44, 55, 66, 77, and 88. So this is the complete workflow how a selection sort works. Now, let us now understand how this algorithm finds the minimum element and what other things this algorithm must do, right? So this algorithm is certain little different from other algorithms that we have already discussed, like bubble sort and insertion sort, because this algorithm requires you to find the minimum element, right? And for that we will be calling a function that is specifically doing this part of work, that finding a minimum location and returning you the value of the minimum location, right? The selection sort algorithm begins as it will be having some n passes, right? K is equal to 1, k is equal to n. Now, we first of all, we need to find the minimum location. So we will call a function which is called as min and had four parameters. The first parameter is called a, that is the array. The second is the k, the pass that we are talking about. N is the number of elements that are there in that particular list or sublist. And LOC is the temporary variable which will be returned back from this particular function call. Once this function call is executed successfully, we will go to the next step, which says we will interchange the AK, that is first position, with the LOC, or AK is equal to 2. I will swap the second position with the lowest value of the array, right? And swapping is done using the same one temporary variable temp. I will store the value of AK into temp, and I will put the value slowest value into AK, and then I will populate the temporary value into the location value. In this way, I will swap this, and I will go and increment the value of K and again go and call the min function. Now let us see what this min function has inside it. The min function initially assumes that the first element of this list or a sublist is the minimum, right? And the location is the minimum element. So this is the assumption that right. So this is the assumption that the function it assumes before it begins to find the minimum element. So it assumes that the first element in that list is the minimum, and this location is the minimum location. It then implement a for loop starting from the next element, that k plus 1. If your k is 1, the loop will go from k is equal to 2 to k is equal to n. If your k is 2, then it will move for j is equal to 3 to j is equal to n. So inside the for loop, there's a condition. The condition says if this minimum number is more than the index another number, right? That means that another number is the minimum. So in this case, what it will do, it will just set a new minimum and then keep on iterating the cycle, right? So to check whether the list again has some lower number or not, right? If it has, then again set to a new minimum and keep on iterating till we reach the last index, right? Once we are the last index and we have set an LOC, we know that we have found a number which is the lowest in that list. So this min will return you back to this selection sort min algorithm and you have the LOC. Now rest step 3 is performed as we have explained to you. Now let us see this complete process of selection sort and the calling of the main function through a dry run on a smaller set of data. So these are the two parts of the complete algorithm. It is written there for you, little distorted form, but it is easy for you to understand that this part is about the selection sort algorithm, and this part is the finding the minimum of an algorithm. So first step is it will call this min part, it will calculate the minimum and return back to you with the minimum location, right? So now let's see how this algorithm works in a step-by-step fashion. So first, let us assume that there is an array called A with values say 3, 7, 1, 4, and 5, right? The total number of elements in this array is 5. So let's begin. If for k is equal to 1, I go and call the min function, right? When I reach this stage of second step of selection sort, the control passes to the min function. And the min function now has four parameters: the array itself, the value of k is equal to 1, the number of element n is equal to 5, and a variable called LOC. You can see that in calling this min function, I have used the concept of pass by reference because I'm passing the complete array inside this min function. So when I go inside this min function, what I'm doing is a k value is 1. So a k is set to min. Now a1 is 3. So for I'm assuming that before starting to find a new minimum, I assume that this 3 is the lowest and the one location is set to 1, right? I will initialize two pointers. One is min and one is location. Now I go inside this for loop for k plus 1, that is 2. From 2 to 5, I will keep on iterating and I will trying to find a new minimum, right? For a2, is a2 more than the min? No, a2 is more than the min. So this is not true. I will not go inside this if condition. I will go and increment the value of k to value of j to next element, that is 3. Now I see that a3 is less than the minimum. So what need to do? I need to just interchange this. I will set the new value to min, right? So you can see that the color changes. 3 was the minimum, right? Now 3, 1 is the minimum, right? And location now is 3. First the location was 1, now the location is 3. So this is now the new minimum. Now I'll iterate with 4. 4 is more than 1, so minimum location is 3 still. Now the next number is 5, which is more than 1, so location is 3 itself and the value is 1. So 5 is the last element of this particular array. So at this stage, the function will come return back to the min, right, to the main selection sort. And now I have the location. A location is 3, a3, right, and ak is a1. So I will interchange a3 with a1, that is k is equal to 1 and location is equal to 3. I will swap these two so I can get 1 at the lowest position and 3 is the third position. So if this is done, my first pass is over and I have sorted one number successfully to its right position. Now I will go and increment the value k is equal to 2 and I will again go and call the min function, go inside this. Now I find the minimum as 3, right? Then if the minimum is 3, I will swap this 3 with 7, right? I will interchange the 3 with 7. I will swap these two, right? Now I have two things sorted. I will move to the third step, right? Now the list is getting shorter and shorter. Sorted list is like increasing in numbers and the unsorted numbers are decreasing in numbers. Now the number that is unsorted is 7, 4, and 5. Then I will sort 7, then I will sort 5. I at this 4 level, my thing has been sorted, right? 7 is the number which is need not to be sorted. It is the highest number. So that's why I move from k is equal to 1 to k is equal to 4. N minus 1. The n minus 1 passes to sort n elements. Hope this selection sort procedure is clear through this working example. Now, at the end of this sorting algorithm, I get the complete sorted list, right? Let us see what is the complexity of the selection sort. First, note that the number fn of comparisons in selection sort algorithm is independent of the original order of the numbers, right? This is one of the like plus point of selection sort, which say that it doesn't depend upon which order the element is present, right? The element may be any order, the algorithm will run successfully, right? The main function requires n minus k comparisons, so there will be n minus 1 comparison in pass 1, n minus 2 comparison in pass 2, and so on. If we sum up all these, we will get the series, and the sum of the series can be represented as n into n minus 1 by 2, which can be written in asymptotic notation as big O of n square. So we saw that the complexity in the worst case for selection sort is again the input or the square of the number of inputs, right? So we can finally conclude that bubble sort, insertion sort, and selection sort, on the worst case, all three have the complexity of n square, right? Now, this is all about selection sort. In the upcoming videos, we'll be seeing another type of algorithms which are called as divide and conquer, right? Till now, we have seen all sorting algorithms which have an order of n square. Next, we are going to study something about divide and conquer type of algorithms. These algorithms have a much better rate of growth than n square. Better rate of growth means it will not have n cube and n to a 4 on any high orders. It will have a lesser order. That means they have a good rate of growth, right? So this is all from my side.